Hello friends, today we are going to look at the general functionality. This means we will look at the brain of the system and the basic rules that make it work across all levels. First, let us understand one thing. Whether a train is running on level 1, 2 or 3, it uses a core set of functions. Think of it like a language. Even if the telephone changes from a wire to a satellite, the language being spoken stays the same. This allows different levels to share common characteristics while keeping their own specific features. Communication, the language of the track. How does the track talk to the train? It uses standardized telegrams. These are digital messages that follows a strict rule book. Because these messages are standardized, a train made by one company can understand a track made by another company. This is the heart of interoperability, the ability for everything to work together. Communication methods by level. Now, the way we send the messages changes depending on the level. In level 1, we mostly use Eurobalises. These are the yellow devices you see between the rails. In level 2 and 3, we move to radio communication. However, even in high-speed radio levels, we still use balises. Why? Because they act like a milestones to help the train verify exactly where it is on the map. Movement authority, MA. If you remember only one thing from this lecture, let it be movement authority or MA. In old systems, a driver looks for a green light. In ERTMS, the system gives the train an MA. This is a digital permission to occupy a specific section of track. The train is under continuous supervision, meaning the computer is always checking to make sure the train never goes an inch past where it is allowed. Train localization. To give a movement authority, the system must know where is the train. The train finds its location relative to the last relevant balise group. It is like saying, I am 2 kilometers past the main station Balise. This reference point is fundamental for the safety of the entire line. Speed supervision control. One of the best features of ERTMS is that it stops human error. The system performs continuous speed supervision. It looks at the track ahead, the curves, the hills, and the train's own braking power. If the driver goes too fast, the system will automatically apply the brakes to keep everyone safe. Driving modes. The system does not always work the same way. We have different modes. For normal high-speed travel, we use full supervision. If we are moving trains in a small yard, we use shunting mode. There are also modes for special conditions, like when a driver needs to drive on site because of a technical issue. The infill function, level 1. Let us look at a specific features for level 1 called infill. In level 1, a train only gets new info when it passes a balise. Imagine a train is slowing down for a red signal, but the light suddenly turns green. Without infill, the train would not know until it reaches the signal. Infill gives the train a hands up early so it can start speeding up again without stopping. Infill transmission methods. There are three ways to send this info early. Infill balises, extra balises placed earlier on the track. Euro loop, a long cable that acts like an antenna. A radio infill, using a radio signal specifically to update the train in level 1. A radio block center RBC. In level 2 and 3, the RBC is the boss of the section. It manages all trains in its area. The size of an RBC's territory depends on how many trains are there and how complex the tracks are. A busy station will have a much smaller RBC area than a long, straight stretch of desert track. RBC handovers and mixed traffic. Since one RBC cannot manage a whole country, they have to talk to each other. When a train moves from one RBC area to the next, they hand over the train like a relay race. Also, the RBC is smart. It has to keep track of older trains that do not have ETCS to make sure they do not get in the way of the high-speed trains. The future, level 3 localization. Finally, let us talk about the future. Level 3, here we want to get rid of the track circuit, the sensors in the rails. To do this, we need a way to track trains continuously. Since balises only give info at specific points, we are now looking at the satellites. Satellite tech, Galileo and GNSS. The systems like Galileo and GNSS are being tested, which are like a more accurate GPS. This would allow us to put more trains on the track because we would know their position perfectly at every second. It also saves money because we don't need as much equipment on the ground. Research projects, G-Rail and EGNOS. There are special projects like G-Rail working on train integrity, making sure train hasn't left any wagons behind. There are also EGNOS, which makes satellite signals accurate enough for high-speed safety. Currently, these are mostly used for low traffic lines, but they are the future for high-speed systems too. To summarize, ERTMS is a flexible, safe and highly digital system. It uses movement authority to keep trains apart, speed supervision to keep them safe, and is moving towards a future where satellites help us manage the tracks. Okay, thank you.